before you move over though, there is this line here at the bottom which represents the end of the data. Of course, when you put in the data over here, the lines had better match up, otherwise one list will be longer than the other and something will be wrong. So your first thing you should notice when you move over is that you have a line that you're going to move down, and this number is punch into 907, and so forth. So I have done that, and I'll wait for you guys to catch up probably faster than me because I had to use a mouse. But notice that the lines here are lined up. That's the first clue that you put in correctly. Obviously, if the lines are lined up, you can see something's wrong. Okay, I can see some people still pushing buttons, so I'll pause here for a minute so you guys catch up. So all we've done, and all we're doing, I guess, is putting in the values for your list 1 and list 2 directly from the list that we're given. Now if we go back and analyze just for a second what they're saying that basically the higher percentage of on base is going to lead to most likely more runs scored, which in baseball makes complete sense, right? This really is just a good starting problem to teach you how this process works. I want to look at this data now in terms of a scatter plot. That's just plotting each point. Remember, we have an x, y. Now, think about this. I'm going to go over here, what we normally do when we hit zoom 6, which takes us to the, I've got stuff in mind. Sorry, hold on. Turn this off. Okay. A couple of things. We hit zoom 6 and we see nothing. We shouldn't see anything. So you shouldn't be seeing nothing on zoom 6 right now. If you look at your y equals 2, the reason that you're not seeing anything is actually twofold. First of all, you need to highlight your plot 1. That's where you turn it on and off. Now the way you do that is you use the up arrow to get you all the way up to the plot 1, and then the enter button will toggle it on and off. I just turned it off. Notice I came off, it's not on. We go back up. I hit the enter button and come back down. Notice it is now highlighted. That is telling the calculator that when you hit graph, it is to go into the setup of stat editor, which we said choose from list 1 and list 2, and make a scatter plot. That won't change, so as long as you turn this on or off is whether we see a scatter plot or not. So if I hit graph now, will I see a scatter plot? You would think so, but yet you don't. What's wrong now? Nope. Yeah, it's there. Take a look at the x values, 33 through what? I don't know what it was. It was in the 30s, I know that. This goes all the way out to 10, right? When you're graphing something that starts with the 30, the x values here. Now what's the y values? In the 700s, right? That's way up there. So we're just looking at the graph in the wrong spot. Now here's where the calculator is really nice. Now pay attention to this. We can go to the window and we can find out the biggest and smallest x that will catch all our x values. And we can do the same for the y. We can look at the y values and pick the biggest and smallest and make that the window for the y's, and we should catch all our data. The calculator will do that exact process for us with a program called Zoom Stat. It's number 9 under the zoom button. If you hit zoom, go down to 9. Careful, you'll overshoot it if you don't. You see it says Zoom Stat. If you hit that, it says, well, I'll just calculate all that for you. It has now, and if you want to check, look at your window. It has changed your window so that all the x values fit and all the y values fit. Okay, that is a time saver. Take a look at yours. Okay. You didn't turn it on. Go all the plot 1. Enter. Now hit zoom 9. Anybody else not getting the scatter plot?
Plot what? Sorry.
That's okay. That's why we're going slow.
Here,
Make
make
sure
sure I have my data.
your plot 1's on. Go up there and turn that on. Go up here, turn that on. Now hit zoom 9. Anybody else have it? Everybody else not having it? Okay. And as we expected, as you increase your your on-base percentage, your runs go what? Up. And they go up in what would appear to be a semi-linear fashion. Actually pretty linear if you look at it, right? More times you get on base, more runs you're going to score. And we're not trying to do anything wonderful here except learn how to use this calculator. So it would make sense to model this data with a line. Now this is where the calculator is going to do most of the work, but we're going to have to use our algebra skills at this point to determine that that data is linear. Nothing saying the data should be linear. Well, the problem pretty much defines a linear relationship. And from the scatter plot, this is only just reinforcing the idea that as you get on base, the more runs you score is linear. So we want to put a line that's going to go through this data. And that's where the stats kicks in. The stats is going to say, well, the kind of line that you would want to go through would be a line that... If you had some data points that generally had a nice upward slope, and you tried to put a line through this data, we could all probably argue all day long about what would the exact line of best fit would be as far as what we thought looking at it. But from a mathematical point of view, a line of best fit would be a line that went through this data, and I'm just guessing at it here. And then if you took the distance from each point to the line, then these little distances that I'm drawing here would be considered the error. How far away from the actual value the line had to travel. And then if we came up with a function or a procedure which minimized the error, would write the line that goes through all the points and is closest to every point by minimizing the error. By making this error smaller and smaller and smaller and smaller for every point, there's going to be some error associated because this thing is not a perfectly straight line. But if we minimized it, then arguably we have the line of best fit. The calculator will do that for you. That's something you'll learn how to do in an advanced stats class. You would spend the entire semester learning how to do that formula. Trust me, it is very complicated. But we have the advantage of this guy. He will do it for us. So watch how this works, because this is not written in any book. You're going to need to refer to your notes to do this again. We will be doing it again and again and again, though, because it's all we're going to do for the rest of the semester. We're going to do linear regression, quadratic regression, cubic regression, perhaps maybe even some power regressions. So let's take a look at this. I want to do a couple of things. First, I want to go to y equals and make sure I don't have anything in my y values. So that's the first step. Clear out all your y equals to. Leave the plot on, of course, but to clear out your y equals. Because we're about to put something there. And then second, quit to get back to the main screen. Task 1 of the project is over. We've created the scatter plot. Now we're going to create the line of best fit. All of this work will be happening in the stats button. So the stats button will be gone to a bunch. So get used to it. Get used to the menu for stats, because we're going to be seeing it a bunch. Notice that we first used clear list option. That was the first thing we did. Then we went to the edit to get the information in. Now we actually want to calculate something. So we're going to move from the edit part of this over to the calculate section. So scroll over to calculate. And if you read down to number 4, it says linreg, which of course stands for linear regression. And notice it says ax plus b. You're used to seeing that as mx plus b, right? Y equals mx plus b. The calculator calls it ax plus b. So a is the slope and b is the y-intercept. A, M, whatever letter they want to use.